I was in the process of investigating some more techniques or discussion of some techniques, and I discovered a little issue. Let's drag the playhead back to this sketch number 4. And actually, I want to show that if you are careful about how you creating your sketches, you can often move them around on the timeline. So I'm going to grab sketch 3 and I'm going to move it back on the timeline, and I'll grab sketch 4 and I'll drag it back on the timeline. And then I'll bring the playhead back, and notice that we can, in this case, because of the way we modeled our geometry, we can have all the sketches visible before we even create any solid geometry. But in the process of doing this, I noticed an issue. This arc should touch at this point right here. I shouldn't even need one of the dimensions that I put in that sketch, because it should be fully defined by the height of the part, the 3.68 inches. So I went back to the original drawing and I sketched a line across, and I see that it does in fact come tangent to this arc. So one of these dimensions we don't need. We either don't need this dimension, but I would think that would be pretty important. That would be a controlling dimension. Or we don't need this radius, or we don't need this dimension where that angled line started. I'm going to guess that really what we don't need is that radius. And so we're going to just make this arc tangent to that point. So I'll go back to my part file, and I'm going to edit this sketch. I need to find out which one it is first. So I'm going to edit sketch 2, and let's rotate this around so we can see what we're doing a little bit better. And then I'm going to P for project geometry. So I'll do P, and then I'm going to project this line from sketch number 1 into sketch number 2, and it will give us that point right there. And so I'll project that, and I'll say okay. Or I could have projected the center line from sketch 1, and I might want to do that instead, because remember we had to add that center line to sketch number 2, and that kind of confused me. I didn't understand why I had to do that because I'd simply forgotten it. But let's go ahead and do that line. So it projects it as a point, and then I'm going to change this radius to a driven dimension instead of a driving dimension. Okay, so now this is a reference dimension, and I'm going to then do coincident between this arc and this point. Now I want to see how much that changes. And so let's go around here and we'll look at that. And I'm just going to turn off sketch number 1. I don't need that visibility on. So right now it's 0.708. I'm going to do coincident this arc to this line, and it changes to 0.704. So it changed the radius 4/1000ths of an inch. I doubt we could even hold that manufacturing tolerance, so I'm going to select that as the dimension I want to change rather than this dimension down here. All right, so now when I finish that sketch and I look at all of my sketches, everything is set up the way that I want it. So I decided to give us consideration to an operation sheet. That is the order in which we will machine the parts. So we have our first operation, which would be the revolve cut on the angle of a cylinder. And then the next operation I decided is to put this hole through the part, and perhaps we could use that hole then for clamping for milling operations. I might also put the fillet though on here as part of the first turning operation. So let's back up one space, and I'll go ahead and do that. Now it doesn't matter if I do that fillet before or after the hole, but I'll go ahead and put a fillet on here, and I forgot what the size is, but we could change that later. I'm going to do 0.0625. That's too big. I put 0.65. I meant 0.0625. And then, so then I have the hole in here. Now I had the hole, when I did that, I went all the way through the part, but I probably don't want to, at least if I drill all the way through, I don't want to tap it all the way through, but let's just change the whole feature. So I'm going to edit that feature, and instead of going through all, I'm going to go a distance, and let's say I'm going to do that distance as, let's say, 1.125. That will get us above the area. Let me turn on that sketch if I can. That'll give us above this area right here, where we're going to end up cutting that out. And I want to give them enough room that I can thread this to that depth. And so let me turn off then sketch visibility on that. and then our M12. And I don't want it to go all the way to the bottom of the 1.125. So I'm going to leave a little bit of space at the bottom of that hole. And actually, I want to put this offset distance, a distance in. I'm going to have it 0 though, offset from here. And then for the depth of this, let's do that as 1.0625. So we'll not quite go to the bottom of this hole. When you're bottom tapping a hole, a lot of times the tap will hit that bottom and break. And so I try to drill a little bit deeper than what my tap is going to go. All right, so I'll say okay to that. And so now it no longer goes all the way through. While I'm on the lathe, I might go ahead and add my chamfer in here. So I will put in the chamfer. And remember, that was a distance and angle. And so let's put in the distance 0.125 and the angle of 15 degrees. Okay, so I've completed that operation. Now keep in mind that this thread is just a cosmetic representation. There are no valleys, peaks and valleys on that thread. For machining operations, we probably don't even want the true thread represented. But if we were going to 3D print this, we would want to go to edit our feature and change this to a model thread, wherever that is in the dialog box here, to change that to be a model thread. Now be careful, do the chamfer in the cosmetic state and then come back and change it to model, but I'm going to leave it in cosmetic. All right, so now we're ready to go to the mill. Actually, maybe we can use the advantage of the hexagon also to hold this in place. So we put on our tooling, we have some kind of hex shape that this fits over, and then we put our screw through that, our fastener, to bolt this down tight. That keeps us from turning on the hex, and the fastener keeps it down tight against our tooling. Then I have to decide on the next operation I want to do, and actually I think I'm trying to decide whether I want to do this operation next. We have to cut through this material, so actually I think what I'll do is I'll actually do this operation next. So I'm just dragging those operations in order. And so then I cut through this area right here. Let's drag this back here. We haven't done that operation yet. Okay, so we cut all that material out. And when we're doing our tooling, we need to make sure our fastener doesn't quite come up to that hole. We end up cutting our fastener, so it'd be a little bit below the top of that hole. And as we're doing our milling, we might go ahead and put a chamfer in at this point, or we could do all the chamfers later. I think I'll do those chamfers later. And then I'm going to drill the hole next. Now, I put the hole into this feature, all-in-one feature. So I'm going to edit that feature and take that hole out. Edit that feature. I'm going to take this hole out, and then I'm going to put that hole though in before I do this cut. Okay, so I'll drag this back and I'll turn on the visibility of that sketch, and I'm going to do extrude, and I'm going to extrude just a circle, and I'll tell it to go symmetric, both directions, distance through all, and we'll say okay to that. So maybe then we could, in our tooling, we could put a pin in here and a pin in here that would help that fastener that we have down here, will help hold that into position so that these two parts of the features don't chatter as we're trying to cut, because we've got a lot of material that we need to cut off of this thing. And so then I do this feature, but I have pins going in these holes that help hold this all into place. Continue on adding my chamfers and to the edges and to this hole. I would break that edge just so that it doesn't gum up a fastener, and also our whatever chamfers we need here. So that gives us some ideas to get started on creating an operation sheet.